Hello, I'm Dr. Sam Hancock of the Emerald Planet and Emerald Planet TV. We come to you on a week-to-week basis from Washington, D.C. in the United States as we look around the globe in 144 different nations, looking for those 1,000 best practices, the technology, services, and products that are making a difference as we move through the 21st century. And as we have a planet of 9 billion people by 2038 and possibly 12 to 13 billion by the end of this century, how are we going to be able to take care of all these people on planet Earth? And that's what Emerald Planet's all about. We come to you looking at the solutions, the best practices from around the globe as we create the Emerald Planet. Hello, welcome to the Emerald Planet. We're making a difference as we move through the 21st century. And seeing the long-term impacts of climate change. We're glad to have you. Thank you for being with us. Looking around the globe, one of the major issues in every country and really all the continents is about water and how we're going to manage water and to increase availability of water for all citizens as we move through the 21st century. I have a gentleman that's joining us from Lisbon in Portugal, and he's a worldwide expert on MARs, Managed Aquifer Recharge. This is something that's actually going on in many countries around the world, but this particular laboratory coming out of the Portuguese National Civil Engineering Laboratory is one of the world leaders. This is Dr. Lobo Ferreira. He's the Principal Research Officer. And Lobo, welcome back to the Emerald Planet TV.
It is my pleasure to be here again, Dr. Sam.
Now, looking at LNEC, why is that so important and why is it so large as far as its outreach and its research capabilities for all of the European Union, but also around the world?
Well, we have established a large network interconnecting the continents because we have the Portuguese-speaking countries there and we have sister laboratories there, and everybody to come to LNEC has to have a PhD degree. So we have like 200 PhDs, and to have a PhD you have to research, and as LNEC is not a university, it's a state research laboratory, we have to apply. So we're trying to apply not only in Portugal, but around the world through our connections.
Mm-hmm. Now, looking at this MAR, this Managed Aquifer Recharge, this is something that is going on in many countries around the world. So why is LNEC so much involved in this? And actually, we're going to be finding out, so integrated with other countries, not only in the European Union, but the Middle East and all Portuguese-speaking countries.
Yeah, as a matter of fact, we have researched and I have developed a model that's turning worldwide to come from precipitation to evapotranspiration, surface runoff, and groundwater recharge. And we are seeing in the last decades, and we have modeled this in Portugal and around the world in our case study areas, demo areas in projects, that really the pattern change is changing. We have much more concentrated events that creates floods, less groundwater recharge, and so managed aquifer recharge is for us in a scientific based way to do what Mother Nature was doing before. We have just destroyed the forest, doing urbanization, etc. It's changing the paradigm that I was willing to do, converting floods not in a disaster problem, but in a source of water when you don't have water in drought years. And we have seen that this amount of precipitation and droughts, the average is still the same. This is good news, but it's much more concentrated. And so if you don't use this to incorporate where appropriated to manage aquifer recharge, the groundwater dependent ecosystems probably will disappear. And that will be a catastrophe for the green, and the Emerald Planet TV is fighting to have them back, okay? So this is a scientific based way. The droughts are increasing. If you look to the map of United States, it's just not a spot. It's concentrated in larger areas and requires different approaches. That's what we're doing.
Now, looking at your motto here, sound, safe, and sustainable strategy, how does Marsol actually exemplify this motto that you have?
Yeah, it's a pleasure to be able to answer to that question. Really, I was invited by Malta. Now the Portuguese presidency is in the European Union this semester. One of the previous semester was Malta that invited me to the next presidency in Slovakia, in Bratislava, to talk to 70 people from the water authorities of those countries that are always afraid of quality. And they have also this obligation to be afraid. But a lot of times they forget what's happening in the Mediterranean area, Southern Europe, like California also. It's not Mediterranean, but the climate is Mediterranean, or Australia, etc. And the quantity, much of the time, is overlooked. So what we would like to say here is that we have proved in so many case studies through our modeling, and we are doing the same here in Marsolut at the moment, creating man-made soils to remove pollution so that we can incorporate in a safe, sound and sustainable way. For instance, let me give an example in northern Italy. The water coming from the Alps, from all those beautiful areas like Lake Como, etc., they have like thunder floods. And then if you incorporate this in large dams, that will create a buffer zone for the floods not going to the Po River, you are able later to release this water in a very nice, appropriate way to be incorporated in the ground where the farmers have over-pumped the groundwater. So floods convert in a source of water and you combat both things. That's what we are targeting to do, and to create the ability in, European Union, where we are having a strong dialogue, that this has to be tested. And the Framework Water Directive allows us to do that. But the water authorities in most of the countries, they are still afraid. That's why we have put this decision maker brief to launch that we know. Of course, we have risks, but we are aware of those risks and we know how to combat those risks.
Yeah, and looking at it as far as Marsol, looking at these various strategies, it's not just one strategy, it's as many strategies as possible in order to capture, sequester, process, and then properly use the water. So looking at the different images that we have here, Lobo, how is this combination helping to even out the ebb and flow as far as water? We have too much 1 month, we're then almost immediately into drought, and it's constantly up and down. How do we level out the availability of water?
Yeah, I love those pictures because those pictures have always a problem. But through the Marsol, we got them to be as a solution, learning for the others. For instance, you have in Israel, it was one of the demo areas that we have, Merkorot, they are reusing like almost 80% of the flash water, the flush water. So you go in wastewater, go to treatment plants, and you reinject it. In Europe, we are a lot far from that area, probably 12% or less. So we are treating ourselves like rich water countries, and we are not. So we were targeting to have water from the wastewater treatment plants, like in Portugal, in the southern area, but also in Israel, in Spain, they were doing in Madrid, having the river and controlling the river for the farmers, and the farmers have learned how to take in account of that. So they are asking, please do manage aquifer recharge because we need. And of course, we have always problems like the cuvetas, is the base ground is just like holes. And then sometimes when the water level is low, the water is not flowing and create problems of water quality. But we were addressing all this through modeling. I was the leader of the WP work package model there. Model is a simulation of reality. So you put everything that corresponds to our world and you test not only on the physical area like this, but you test. You see myself in a red shirt there trying to have an experiment, a tracer experiment where we have several piezometers. You inject this water with a tracer, and then you detect later what is the response of the ground, underground, the aquifer. So you plug in the models, the values that we've detected there. But we have also difference, like I was telling you a little before, in over this MA Marshall letters. You have CB in northern Italy, precisely what I was saying, coming from that dam from the Alps. You have water that went down by over pumping. Now you have a forest or just a tree orchard there, but you put like canals in between. So it's absolutely nice, natural-based solution, and we are treating this in such a way. So we are using rainwater in the wets or this ephemeral rivers that we have so much in California. You have fantastic know-how available there, like the insufflatable dams also. When it rains, you put like an insufflated dam and you create the water pressure to go in. And so the application worldwide that you're trying to learn from each other is great. You were saying that we have this around the world. We have an ISMAR, so is people every couple of years to join. Last one was in Madrid. I was in Abu Dhabi before. And so like 300 people were showing how to apply in Namibia, in the sponge cities in China, in Brazil, the similar concept of sponge cities there. So in Chicago, I was there in Chicago, and we have parks in Chicago where the kids are playing in the ground, but it's just like a soup dish. You don't notice, but when it rains, the water stays there. You don't allow the kids to go, and this water goes slowly to be released. So this is very nice. It was just not so long ago, 96, the first ever diffuse pollution seminar in in Chicago. This is all novelty. So through EmeraldPlanet TV, I think that we can say to the others, we trust on the solution. Let us try to apply.
Right. Now, looking at this very complicated system, I put this up here. You shared this with us, but let's look at it in reality. What are we seeing here, and why does this work? And is the complexity that we're seeing needed? And we only have about time for one more question, so we have to be quick.
Yeah, you know, the Algarve is a very nice place for the Europeans, probably the best place to go in holidays selected by the travel agencies. And then you have a lot of people in summertime before the COVID, and then you have much less people. So we have dimensioned this wastewater treatment plant. And you see the small dots there, these two small basins. We are trying to take without energy, so gravity flowing. Instead of going to the rivers with a lot of nitrate, you just put them through these basins where we create the man-made soil to remove the pollutants to go to the streams that afterwards go to the aquifer. So removing the pollution, and then make this useful for agriculture with the control, the protocol of the quality that the Portuguese government is trying to say to the farmers. You need this type of quality. We are able to give you this. So don't use for lettuce, use this for orchards. So the control of quality is a must. We are trying to test here. And also in the lab, the picture before, it was just the cut of this. You see, you have the basins there, and you are simulating in a model, reduced model in LNEC precisely to correct this and to remove the hydrocarbons, pesticides, so that we are in the safe side in quality too. I do believe.
Okay, Lobo, we got 30 seconds.
Thank you.
Looking at the future, what do you see as far as this type of program?
Well, we have to incorporate the industries so that we are able also to rehabilitate the water coming from the industries so that they are just self-contained, and sometimes they can plug then in the soil the water they have, also the temperature, and pump it back. And the farmers, they are doing that. But for most, saying to the water authorities that can rely on the science, because we are creating a network around the world, and we are here to help you scientific based.
Fantastic. Dr. Lobo Ferreira, Principal Research Officer, LNEC, thank you for being with us as we create the Emerald Planet.
My pleasure.